Let's continue talking about functions. Let's focus on the domain and the range. So what's the domain for each of the following functions? All right, so we look at this first one. And when I ask what's the domain, I'm thinking what values can I plug in for x that won't cause me a problem here? So if I picked a number like, I don't know, 10, I could do 1 divided by the square root of 12. That would be fine. What if I picked a number like 100? Sure, I could do 1 divided by the square root of 102, and 598, etc. I can pick as big a number as I'd like and plug it in, and I'm not going to have any problems with that. But what happens if I start to pick numbers that are smaller? What if I pick 0? Well, then I get 1 divided by the square root of 2, and that's still okay. How about negative numbers? Could I pick negative 1? Well, then I get 1 divided by the square root of 1, which is 1, and 1 over 1 is 1. That's fine. But notice what happens when I get to negative 2. Then I'm going to get 1 divided by the square root of 0. Now, it's okay to do the square root of 0. The square root of 0 is 0. But once I do that, then I'm going to get 1 divided by 0, and that's a problem. That's undefined. We cannot divide by 0. So I can't pick negative 2. How about something that's smaller than negative 2? Well, once I do that, in my denominator, I'm going to be getting 1 divided by the square root of a negative number. And we can't take the square root of negative numbers, at least not in the real number system. And that's what we're working in right now. So in terms of what is my domain, I can pick anything that's bigger than negative 2 all the way up to infinity. And so I'm going to use interval notation. And if I wanted to include the negative 2, I'd use a bracket. But if I'm not including it, I'm going to use a parenthesis. And infinity isn't a number, so we always use parentheses for infinity. If I wanted to write this with inequalities, I could just say x greater than negative 2. But I want to start getting used to writing interval notation instead of using inequalities, although either one is fine. Okay, let's look at the next example. What is the domain for this function? Well, this is in a different form here. It's a set of ordered pairs. And so the first element in the ordered pair is the x value, and the second is the y value. So the domain would be all my x values. So 1 and 2 and negative 4 and 0. It's not a range of numbers, though. It's 4 specific values. So I'm not going to use interval notation here. I'm going to have to use set notation. And so D for domain. And it's going to include, and you don't have to do this, but I'm going to put it in ascending order. And we get negative 4, 0, 1, and 2. And that's it. There's 4 numbers that are in the domain for this function. This is a finite function. The other one was infinite. All right, how about this example? Now we're going to have a graph. Use my arrow with that. And let's find the domain for this function. So basically I'm looking for what are the x values. And as you can see from the graph, this open circle means x is not going to equal negative 4. But anything to the right of that is valid until we get to this x value, which is negative 1. And then we have these values for x, and then nothing in between here. And then at x equals 4, we have a point on our graph. So what I like to do is use my domain detector to help me figure out what's the domain for a function. Now, it seems a little silly, but what I'm going to do is I'm going to slide this thing across the screen. And the domain detector beeps when it hits the graph. So it's not going to beep until right here, and then it's going to start beeping, and then it's going to stop for a little bit, and then it's going to start up again, and then it's going to stop, and then it's going to beep one more time. So as I'm running it across, we get a beep, 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 stops, and then beep, 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 stops, and then beep, and then stops. And so all the places where it beeps, where it hits the graph, those are x values in my domain. So let's list those. And I'll use interval notation. So we start off, it's not beeping at x equals negative 4. Now remember, we're talking about the x values here. So we're thinking of these x values on my horizontal axis. So it's not going to beep at -4, but then it's going to beep anything greater than -4 until we get to 1 and including 1. So we're going to go -4 to 1. We're not going to include the -4 because it's an open circle, so we use a parenthesis, but we are including the 1, so we're going to use a bracket. So that's the first part of my domain. Now nothing happens until we get to x equals 0. It's not beeping there, but as soon as we get greater than 0, all the way until we get to 3, it's going to beep. So I'm going to put a little u for union, and then we're going to go from 0 to 3. And once again, we're not including 0, so parenthesis. Include the 3, so put a bracket. And then, union with, it's going to beep one more time, but not for an interval of values, just for one specific value. And that's at x equals 4. So I'm going to have to use set notation here, and use the set symbol, and just the single number 4. And so there you go. There's your domain for that. All right, let's look at one more example. Find the domain for this function. It represents the area of a circle, and we have a equals pi r squared. So first thing I want you to realize, let me just cross this out. If this was in here, and we just saw a is equal to pi r squared, a is our dependent variable, kind of like y, and r is our independent variable, like x. So my inputs go into r, I square it, multiply by pi, and that gives me my output, my area. So the input is r. So what can I put in for r? Well, I don't have any problems mathematically. When I plug in any number for r, I can square it, multiply it by pi. I could plug in positive numbers, negative numbers, 0. They're all fine. But this problem did specify what these letters represent. And it's telling us that it's the area of a circle, and r represents the radius of the circle. And so we know a circle has to have a radius that's greater than 0. So my domain is going to be anything greater than 0, but not including 0, so I'll use a parenthesis. And there you have it. Okay, so different representations, and that's how we can specify the domain for each of those. Now let's go back and let's find the range for each of those functions. Well, we'll work with number 4 since it's right here. A represents the area of a circle. So just like the radius, I'm going to put r here for range. The area can be anything greater than 0. So I'm going to say 0 to infinity, and we're not going to include the 0, because if the area is 0, it's not a circle. And that's our range. All right, let's go way back up to the first example. And let's find the range for this. Now this one's going to take some thought. You know, sometimes it's easy, sometimes it takes a little more work. So I want to figure out the range. So I want to figure out the outputs. Now I know I can put in numbers greater than -2, all the way to infinity. I can plug them in here. So let's think about the really big numbers. If I plug in a big number like 10, I get 1 over the square root of 12. If I plug in, let's say 100, I'm going to get 1 over the square root of 102. If I plug in, let me write that one down. Let's say I plugged in 98. So I'm going to get 1 over the square root of 98 plus 2, which is 1 over the square root of 100. And the square root of 100 is 10. So I get 1/10. What happens if I plugged in something bigger, like how about 998? Or how about I plugged in 1,000,000? Let's count all the zeros there. Okay, you can see what's happening with my fraction. I'm getting 1 over bigger and bigger numbers, and 1 over a really big number gives you a really small number. So as x is getting bigger and bigger and bigger, my input's getting larger and larger and larger, the actual value for f of x is getting smaller and smaller and smaller. I'm getting 1 divided by bigger and bigger numbers, which is giving me numbers closer and closer to 0. Okay? I'll never hit 0. I can never get 0 from this expression. But the bigger I plug in the numbers, the closer I get to 0. Now, what happens is I start moving the other way. What if I plugged in, oh, I don't know, let's say -1. I get 1 divided by the square root of -1 plus 2, which is 1 divided by the square root of 1, which is 1. And 1 over 1 is 1. Okay, so remember I was getting really small numbers. Now I'm getting 1. What if I plugged in a number even closer to -2? How about I plugged in, oh, I don't know, -1.9? Well, what's going to happen there? Then we're going to get 1 divided by the square root of 0.1. That's 1 divided by the square root of 1/10. What's that? That's 1 divided by the square root of 1 is 1 and the square root of 10. And so we wind up getting the square root of 10, which is about 3 point something. So as I'm picking numbers that are getting closer and closer to -2, I got 1 and then I got 3 point something. Let's keep going. Let's get, how about 1 divided by the square root of, what if I did -1.99 plus 2? Then I'd get 1 divided by the square root of 0.01. That's 1 divided by the square root of 1 over 100. But wait a minute. Square root of 1 over 100 is 1/10. 1 divided by 1/10 is the same as 1 times the reciprocal of 1/10. And I get 10. My answers seem to get bigger as the values I'm plugging in for x are getting closer and closer to -2. So if I got even closer to -2, like -1.999, I'm going to get stuff like 1 over 1,000, or 1 over, and so that's going to be 1,000. Or I'm going to get 1 over 10,000, and that's going to wind up being 10,000. So as you can see, the bigger, or the closer I get to -2 when I plug it in here, the smaller this is becoming, and I'm taking the square root of that, which is getting even smaller, and then 1 divided by a really small number is giving me a really big number, bigger and bigger and bigger and bigger. So the closer my input gets to -2, the larger my output is getting. And the closer x is getting to infinity, this becomes 1 divided by a really big number, which is almost 0, the smaller my output. So it looks like for my range for this one, I'll never quite get to 0, and then it'll go all the way to infinity. So that one takes a lot of thought, and you might have to go back through that and think through it a little more, or maybe take some more time and plug in some x values to see what you get, or use some kind of a table or spreadsheet to see that that's actually what's going on. All right, let's go down to here. This one's going to be a lot easier. What's the range for this function? Well, the range are the outputs. The outputs are the second coordinates. So that's it. I've got a 7, a -3, a 1, and a 7. I'm going to put them in ascending order once again, but I'm using set notation because they're specific values, not a range of values. So I have a 7, a -3, a 1, so I'm going to put a -3 first, then a 1, then a 7. And now notice, you don't have to repeat the 7. 7 is an output. It happens twice. It happens here and it happens here, but we only list it once in our range, because then it's covered. All right. And then we have one more, and that was our graph. And so for our graph, I'm just going to use my range finder, which is very similar to my domain finder. And when I slide this vertically from y = -infinity to y = infinity, it'll beep whenever it hits the graph. So when's it going to beep? Right there. At that specific y value. What's the y value there? -4. Let me grab my arrow. Put that back here. Okay. So notice the y values now. We're looking at the vertical axis here. We're looking for the y values, not the x values. So the y value here, when my range detector hits the graph, y is -4. Then it doesn't hit it again. Oh, it hits it here. What's the y value? +1. And then it's going to hit it here. My y value is 2. It'll continue hitting the graph to 3, up until, but not including y = 4, because we have an open circle. So once again, what are my outputs? What are my y values? -4, 1, and then from 2 to 4, not including 4. So let's write that out. First, we had a specific value of -4. So I have to use set notation here, -4. And then a specific value of y = 1. So that's still set notation. Notice this is not saying the interval from -4 to 1. It's saying the values of -4 and the value of 1. And then from 2 to 4, including 2 but not including 4. So I'm going to put a little union here. And we're going from 2 to 4. Include the 2, so we use a bracket. Don't include the 4, so we use a parenthesis. So there's how we get our domain and range for various examples.